to today's lesson. Rather, we are still under numbers and numeration, and we are doing number base. In number base, basically, I think for now the highest they teach as mathematics in secondary school is up to base 16 as hexadecimal. But we have base 1, base 2. No, we don't have base 1. Sorry, base 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So basically, I'll not really go much into that. But base 2 is known as binary. We have octal, that's base 8. We have decimal, that's base 10. That's our standard counting numbers. And we have hexadecimal, that's base 15. Now let me give you an instance. We have 0, we have 1, 2, 3, 4, 5, 6, 7. Let me stop there. I'll continue, right? But I want us to understand something that's very, very paramount and important, because when we are dealing with bases, right? We need to understand that in each basis, for example, we're starting with base 2. In base 2, the number must not be up to 2, it will be zeros and 1. It's the same thing as when we are adding 89 plus 24. 9 plus 4 is what? 13. We cannot put our 13 here. We have to carry it to the side. That's the same rule that applies for all bases. For your base 2, the numbers you're supposed to work with is with zeros and ones, right? For your base 3, 0, 1, 2, like that. For your base 8, you stop at 7. The numbers must not exceed 7, right? For your base 10, the numbers must not exceed 9, right? Then after base 10, we have what we call A, B, C, D, E, F. A, B, C, D, E, F. Now these numbers, they represent 11, 12, 13, 14. 10, 11, 12, 13, 14, 15 for hexadecimal. So it stops at 15, right? It's the same process. Now, in looking for base 16, right? They can give us 7, 9, 8. We don't know what base is if they did not tell us, because it can act as base 11, it can act as base 12, it can act as base 13, base 16. The same way 01 can be base 2. 01 is still in base 6. Do you get it? Now I'll show us some things to make us understand. So we are going to convert. We are doing conversion of decimals to binary, meaning that we are converting conversion of decimal to other bases. But first, we'll do conversion of other bases to what? Base 10. We're doing conversion of other bases to what? Base 10. So that's what we'll be looking at first. Conversion of other bases to base 10. So, conversion of other bases to base 10. So, let's give examples. We have 2, 1, 2, base 3, 0, 1, 1. Okay, let me note 1, 0, 1, 0, 1, 1, base 2, 5, 4, 1, 2, base 7, 2, 1, A, B, base 12. Let me say base 14, and let me just use base 12. Base 12, and let's just use this one, right? Let's use this one. Now, we're going to solve. Number 1. Now, you see that this number is not up to base 3. If you have 2, 1, 3, it can never be base 3. It must not be up to the number of the base, right? So, in converting from other bases to base 10, right? What do? We multiply the other base, or we give them a power. Now we are going to start from the last. What's the last number? 0. So 2 rather. We give them a power starting from 0, 0, 1, 2. This is where we can stop. But adding the other numbers, we continue till where it can stop. So basically, we are going to do pick 2 times, what base are we doing? 3. The next one, plus 1 times, what base are we doing? 3. Plus 2 times 3. Now, these powers that we put, right, is for this one. This power is for this one. This power is for this one. But we are putting the power on the base. We have base 3, putting the power here on the base, putting the power here on the base, and 1 on the base, putting the power here on the base. Right? So what we're going to have next is what? 2 times 3 raised power 2 is 3 times 3. That's what? 9. Plus 1 times 3 raised power 1 is 3. Plus 2 times 3 raised power 0. Anything raised power 0 is what? 1. So 2 times 9 is 18 plus 3 plus what? 2. So our final answer will be what? 23 is 10. We write it like this. It's 10. That's it. So for the number 2, we have 1 0 1 0 1 1 base 2. The same process, put your 0 1 2 3 4 5. So we have 1 times, what is the base? 2 plus 0 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. So we put this on the what? Their bases. 0 1 2 3 4 5. So we have 1 times 2 raised power 5 is what? 32 plus 0 times 2 raised power 4 is what? 16. That's 2 times 2, 4 times 2 times 2 times 2 times 2. That's what? 16. Plus 1 times 2 raised power 3, 2 times 2 times 2. That's 8. Plus 0 times 2 raised power 2, 2 times 2, 4. Plus 1 times 2 plus 1 times anything raised power 0 is what? 1. Are you following? So we have 1 times 32 is what? 32. 0 times 16, anything times 0 is what? 0. Plus 1 times 8, 8. This is 0. 0 times 4 is what? 0. Plus 1 times 2, 2. Plus 1 times 1, 1. So we have 32. 32 plus 8 plus 2 plus 1. 32 plus 8 is 40. 40 plus 2 is 42. 42 plus 1 is what? 43 is what? 10. Oh, wow. Sorry for this. Sorry for the way I'm dividing my board. We have number 3. We have 5, 4, 1, 2 is what? 7. As you can see, we're supposed to have 6. If you have 6 here, it's still correct, right? But it doesn't mean. So we have 0, 1, 2, 3. So we have 5 times the base 7 plus 4 times the base 7 plus 1 times the base 7 plus 2 times the base 7. So we put the power on their bases 0, 1, 2, 3. 5 times 7 raised power 3 is what? 7 times 7 times 7. That's we have 343 plus 4 times 7 times 7. That's what? 49 plus 1 times 7 plus 2 times anything raised by 0 is what? 1. Are we following? Are we following? So here should be that's 1,715. Yes, 34. Yeah, it's correct. 1,715. Then here we have 4 times 49. That would be 196 plus 7 plus 2. Right? So we should have 171,196. This is 198. This is 205. 205. We add a 5 to here as 1,720 plus 200. So everything should be 1,920. Is what? 10. Is 10. Now, number 4, we have 2, 1, 3 is what? 12. So what are we going to do? 2 times what? 12. Abi plus 1 times 12. Oh, sorry. 0, 1, 2, 3. 1 times 12 plus 8 A in this place, A is our what? If you can remember, A is 10, right? B is 11, C is 12, D is 13, E is 14, F is 15. So A here is 10. So we are going to do it 10 times 12 because we are multiplying. So plus 11 times 12. So 0, 1, 2, 3. 2 times, wow. 12 raised to the power 3 ish. I think it should be 17 something. I'm not on my calculator now. But 144 plus 2 8 8. So I think 1440 so 8 as 1728. Then plus 1 times 12 raised to the power 2, right? Raised to the power 2. 12 raised to the power 2 is what? 144 plus 10 times 12. 10 times 12 is what? 120. Let's just do straight. Or let's not do straight. Let's do 10 times 12 plus 11 times 1. 8 raised to the power 0 is 1. So we have 2 times 1728. We have 3, 4, 5, 6 plus 144 plus 120 plus 11. So what we will get 44 plus 3536 36 plus 121 3721. Yes, if I'm not mistaken. Yes, that's it. So base 10. Now I'm still going to use this example to do conversion of base 10 to other bases. So conversion of base 10 to other bases. Now I will try to be cleaning it as I'm doing it so that you will see conversion of base 10 to other bases. Conversion of base 10 to other bases. For example, we're not using this example now. If you say convert, number 1 was our answer 23. You say convert 23 base 10 to base what? Base 3, which was our original form. Then the next one is 43 base 10 to base what? 2. The next one, what do you get? 1920 base 10 to base 7. And the last one, 3721 base 10 to base what? 12. Now we're going to start our solution from here. Let's no, let's rather start from here. So now in conversion of the bases, we are to look at something. We are doing like a division, right? Linear division. So if we have 23, we put our 23 here to base what? To base 3. Now we do it like this. How many 3 can you see? 23 is what? 7. Something will remain. We have remainder 2. How many 3 can you see in 7? We have what? 2. Remainder 1. Then whenever you see that this is already less than the number, so how many 3 can you see here? You cannot see anything. 0. We bring back to this one. Remember what? 2. So the arrow goes like this. We have what? 2 1 2. 2 1 2 is what? 3. Are we following? Let's do the second one. Second one. We have 43 base 2. So we put our 43 here. We put our 2 here. How many 2 can you see here? You see 21. Remainder what? 1. That's the remainder. It's the remainder that gives us the base rather. So 2 here is what? 10. Remainder 1. 2 here is what? 5. There is no remainder, so we'll put remainder 0. 2 here is what? 2. Remainder 1. 2 here is what? 1. Remainder 0. Now, how many 2 can you see in this one? We must not leave it until it is 0. So 2 remainder 1, we cannot see anything, so we'll put it 0. Then we'll bring this one remainder 1. So like this, we have 1 0 1 0 1 1. Base what? Base 2. It's as simple. Then let's do the last two. And let me do the last two. I'll just show you something and we are done for number base. The last two, we have 1920 base 7. How many 7 can you see here? We see 2, 5, 7, 3, 4, remainder 2. You can use your calculator. Yes, yeah. And how many 7 can we see here? We see that's 3, 6, 9, remainder 1. Yes, that's it. How many 7 can you see here? We see 5, remainder what? 4. Right? Then how many 7 can you see here? 0, bring this up, remainder what? 5. Right, so we have 5, 4, 1, 2. Right, 5, 4, 1, 2. Then is what? 7. And this one is for number 3. This for number 4. Alright, sorry, before we proceed, I noticed there was a mistake. It's 3 7 3 1. Why? Because if you remember that time we had 2 times 1 7 2 8, I think, then plus 1 times 1 4 4 plus yeah, that one was what? I know this one was 11 times 1, so it was 12. What was here? I think 2. Was it 2? 10. Yeah, 10. So let me show you the mistake that was here. Here was 3 4 5 6 plus 1 4 4 plus 1 20 plus 11. So the mistake was, if you add these two, yes, what you are going to get is 3 6. And if you add this one, you get 3 7 20. If you add this one to be 3 7 3 1, because this will be 3 7 21. So 3 7 21, because this one is 3 7 20. So plus 11, 3 7 21 31. So that's the mistake I made in that place. So let's quickly do for 3 7 3 7 3 1 to base what? To base 12. So we have 12, right? 12 in 37 3 7 3 1, rather we have 300 and 310, remainder 1, not remainder 1, remainder 11, right? Remainder 11, and I told you your 11 is what? Your B. Your 11 is your B. Your 11 is what? Your B. So here we have 12, right? 12 in here will have as 25, right? Remainder 10. And your 10 is what? Your A. Your 10 is what? Your A. Right? Your 10 is your A. So here we have 12. 12 in 25. We have that's 2, remainder 1. Right? 2, remainder 1. Then your 12, 0, remainder 2. Right? 0, remainder 2. Sorry for that. So quickly, we are quickly going to sort something, because we are through with number base, but they might give you a question like this. They might tell you just peradventure, and most times it leads to quadratic equation. So they might just give you 2 1 2 base x, and is 10. That's for start. So basically just do 2 times x plus 1 times x plus 2 times x 0, 1, 2. Then this was already base 10, right? We are converting to base 10, so we just put our 10. This one is 2x squared plus x plus 2 equals to 10. Then bring this one, 2x squared plus x plus 2 minus 10 equals to 0. 2x squared plus x minus 8 equals to 0. Now this form, we have to do it in what? Quadratic equation. Now this is the type of thing they give you in WAEC and NECO, right? But I cannot do it now because I've not really uploaded the video of what's quadratic equation. So basically, once you do it, just solve for quadratic equation from here. But let me give you, they can give you also in this form where they give you, let me use this 2 1 again, 2 1 2x, and they give you 12x. So the same thing you did here is the same thing you do here. So all you are going to do is 2 times this 0 1 2 0 1, 2 times x. Let me use 32. So 2 times x plus 1 times x plus 2 times x equals 3 times x plus 2 times x. This will be 0 1. This will be 0 1 2. So we have 2x squared plus x plus 2, because this one x plus 0 is 1. 1 times 2 2. Then we have 3x plus 2. So you collect like this: 2x 2 plus x. This one 3x. 3x cross equals to side becomes minus 3x. Then we have what? Plus 2 minus 2 equals to 0. So basically we have 2x squared minus 2x plus x minus 3x. We will deal with that in algebraic equation. Oh no, let me just rather do it here. We have plus 1 minus 3 plus 1 minus 3, right? Whenever you see a smaller number here, doesn't know automatically your answer is negative, then switch it. 3 minus 1 is what? 2. So that's why we have minus 3x, and this one is 0 equals to 0, because 2 minus 2 is 0. But some cases they will not give you. This is the quadratic equation. We are going to learn how to solve this type of quadratic equation, but this is where I'll stop for number base. And when we do quadratic equation, you understand how to solve this better. You understand how to solve this better. So yeah, we are through with number base. Please make sure to like and